Welcome back, physics fans, and here we're going on with number 26 and 27. Yeah, we skipped a couple numbers because the worksheets actually skip a couple numbers. I'm not choosing every one from my Physics 11 worksheet. I'm just choosing some of the more challenging ones. So here's number 26. Pause the video, try it ahead of me, see if you can get the answers. Let's start. 5, 4, 3, 2, 1. Here we go. An 100-kilogram object is moving at 20 meters per second, comes to a stop over a distance of 40 meters. What is the coefficient of kinetic friction between the ground and the object? So the object is, assuming that's on a horizontal surface, there's friction, so it has to be on a surface. There's a force of gravity. And I'm going to say the force of friction is this way. Why? Because, not the acceleration, sorry. The velocity is this way. I'm choosing the velocity here. So friction is going to try to slow it down. So what is the force to the right? The object's moving to the right. What force is there? There is not a force to the right. An object moving to the right doesn't have to have a force to the right. An object in motion maintains its motion, and it'll keep on its motion to the right, in this case, as long as all the forces are balanced. But then all of a sudden it hits some friction, and it comes to a stop. Okay? And then they're asking, what is the coefficient of kinetic friction between the object and the ground? So in the direction of motion, which is that way, we're going to have acceleration that way. It's going to slow down. We write down Newton's second law. Sum of the forces equals F net equals ma, always. As soon as you draw a free body diagram, boom, you can draw this Newton's laws out. That's what you should do, Newton's second law. There's only one force. The force of friction is equal to ma. The left is winning. And then we got mu mg is equal to ma. Again, it's on the surface. Why can I do that instead of writing mu n? Because the force of friction, the sum of the forces in the y direction, up and down, are 0. So we have the upward force is equal to the downward force. And the upward force is the normal, and the downward force is the force of gravity, which is just mg. So I can substitute in the force of friction formula. Force of friction is equal to mu n, and in this case it's mu mg. Okay? So we could figure out what we're trying to solve for this. So I guess we need everything else. So let's calculate the acceleration. So let's do some kinematics here. Let's change the color to black. Some kinematics. We want A. So we have that its initial velocity is 20, its final velocity is 0 because it stops, and the distance that it traveled, or displacement, was 40 meters. Okay, so calculating this, we're going to use Vf squared is equal to Vi squared plus 2AD. 0 is equal to Vi squared. So that's 20 squared plus 2 times a, that's what we're trying to find out, and the distance is 20. So I'm going to take this over to the other side, and we're going to have negative 40a is equal to 400, because that's what 20 squared is. So we're going to get from this that acceleration is going to be negative 10 meters per second squared. Okay? Negative because it's in the direction that I chose positive. I chose to the right positive. But we now know, obviously, it is negative because I told you that acceleration is in the opposite direction. So I don't put negative in here because in my Newton's second law here, I said the winning force, which is positive, is to the left. So this will be positive acceleration that I put in here. So mu 100 times 9.8 is equal to 100 times 10. I can cancel the hundreds out if I want to. So mu is going to equal, did I do something wrong? Yeah, I did something wrong. The stopping distance was 40. All of a sudden I'm seeing, oh, coefficient of friction, that's going to be a little higher than 1. That's a weird question I would give. Boom. There we go. Put that in my blooper reel. That's supposed to be 440. Okay, so this is going to be 80. And that is going to make the acceleration 400 over 80, which is negative 5. Okay, so let me just use my eraser here. Sorry, I'm glad you guys were vocal there. Online there, I bet you left lots of comments already. This will be only 5. So this is going to be 500 over 980, and that mu is going to equal 0.510. So that is the coefficient of friction to make this happen. Sorry for the mistake. Let's try number 27. Get a head start on that, please. And that's a hockey puck is hit on a frozen lake and starts moving with a speed of 12 meters per second. 5 seconds later, the velocity is only 6 meters per second. What's the coefficient of friction of the puck on the ice? We don't have to worry about the hit. The hit made it have this velocity. We're not asked to find out what that was. We're asked to find out after the hit what was it slowed down, what's the coefficient of friction. There's the hockey puck and free body diagram, normal, force of gravity, there's a frictional force, and it's moving this way, velocity, but its acceleration is this way. There is no force here. Don't draw a line here. That's not supposed to be there. There is no force to the right. It's moving to the right. Doesn't need a force to move it to the right to keep it moving at 12. Okay, let's do the kinematics first. Last time I did the kinematics second. I'll do the kinematics here because I know I'm going to use F equals ma, and I'll need A. So it's going 5 to 6, 12 to 6 in 5 seconds. So the initial speed is 12, the final speed here is 6, and the time here is 5 seconds. So the acceleration is going to be Vf squared minus Vi squared all over, whoops, wrong formula. I thought it was last formula too. It'll be Vf minus Vi all over T. Woo! So that's going to be 12 minus 6. Oh, 6 minus 12. All over a time of 5. So the acceleration here is going to equal 6 over 5, or about 1.2 meters per second squared, and it's negative. It's obviously negative. It's in the opposite direction of motion. It's slowing it down. Newton's second law now. Sum of the forces is equal to F net equals MA. What's winning? The force of friction, so that has to equal MA. The force of friction is mu mg, which is equal to MA. Why is it mu mg? It's supposed to be mu m. Well, the forces in the y direction are equal to 0. The upward force equals the downward force. The upward force is the normal, and the downward force is the force of gravity, which is mg. So when we change over to the force of friction, which is mu n, I can substitute that with mg, mu mg. You getting tired of me doing that? Well, I'm just trying to be efficient, showing why I'm doing it. You can't just assume that you can do it, because when you assume, you know what happens. The masses here cancel out. I can do that mathematically. I'm not going to be able to calculate what the net force is or what the frictional force is. I won't be able to get you MA because I've canceled out the M's. But I still will be able to calculate mu is. Mu is going to be A over G. So that is 1.2 over 9.8. And so the mu here is 0.1224. Thanks for watching. If you have any questions, leave them in the comment section down below. Click like. I like people who like my videos. Subscribe. Hit the 10 out replay and follow future.